Hi everybody. We are at leetcode.com. Let's start with the easy task. The first task which I chose, for some reason it has number 19, I don't know why. It's called remove nth node from the end of the list. So I'll give you some time to read that stuff. Let's look at an example. We have a linked list. Everybody knows what linked list is? Just to quickly recap, this is a structure where we have an element which can contain a value. In this case, it's 1, 2, 3, 4, 5. And it also has a pointer to the next element. So in this case, 1 has a value of 1 and points to 2. Then this guy 2 has a value 2 and points to 3. And then last element points to none or null or empty or whatever. So that's basically it. We also have a double linked list, and they have 2 pointers to the next and to the previous element. But in this case, we have only single linked list, so it has only a pointer to next. So given that linked list and a number n equals to 2, we have to remove this second node from the end. We don't have just to cut this thing so that it has only 1, 2, and 3. We have to remove this 4, this second element from the end. In their understanding, the first element from the end is 5. It's a bit strange because programmers count from 0, but you can see they also start from 1 and not from 0 here. So let's just assume they don't know zeros. And they have to, we have to remove 4, but keep 5. So that the final result will be 1 to 3, then 4 is missing, then 5, and then none. Okay, let's also pay close attention to nodes. They usually have some interesting, important information. N will always be valid. That's quite good. It means that we will not see n equals to million or 5. Actually, 5 is okay. 100 or whatever greater than the number of elements that you have in the list. That's really good. So you don't have to double check anything. Then try to do this in one pass. What one pass means is that you pass this list only once. You don't do some calculations through the full list first, and then you do another set of calculations on the full list. So just do one pass. They don't say that we cannot have 2 pointers though, and that will be the approach that we'll take here. Okay, let's go down. So here we have a solution place where you write your code. And also notice this checkbox. It shows you with which test it will run when you click Run Code. When you submit solution, it will run multiple tests on your code. But when you just run code, then it will run that stuff. And you can actually provide your own set of inputs here. And this online judge, will guess what the output is because, I don't know, it will run the same input on its ideal solution and then plug the answer is and compare the answer with your answer. I don't know. I guess so. So you can use this default input or provide yours. That's it. Okay, let's look at this thing. So we are using Python. I don't know, I chose Python. You can choose whatever you want, even MySQL, right? But yeah, I don't see MySQL here. But popular solutions are Ruby, JavaScript, Java, Python, many of them. So then we should look at this section. This section says what will be the expected type of the arguments which are passed to this entry point function or entry point method. So self is okay, just have to skip it. This is the object because for some reason we have a class here with the method instead of just a function. So let's just skip it. But then we have 2 arguments, head and n. So head will be of type list node, and they already provide this class called list node, which has a constructor which takes a value. In this case, it's x, but they set this x into the val attribute of the object, and then they just assume that there is nothing else after this node, so they set no next to none. Okay, so now we know that head has the type list node, and n is just int. Oops, sorry, this guy. And then in the return, we have to return list node as well as a result. Sorry. So let's try to code the solution, shall we? Now, guys, we have to look very closely at many things. First, we have to look at examples. So this is an example. Then this is another example. And we have to understand what we will be doing here. So what I propose is to plug few examples straight in the comments, or you can also do like assert and solution dot remove blah blah dot, and then we will give some input to it. Yeah, let's uncomment this guy first. Like list node of one or just one, then yeah, we can actually create that stuff first. List one equals list node one, and then list one dot next equals list node of two. So we can create some basic list here and then just say, okay, that should be equals to one. Why is that? Because we've created a linked list with two elements. The first element is 1 and the second element is 2. And we removed first element from the end. So this is this guy 2. We removed 2. So the answer should be just first element. Yeah, I know I have a lot of magic numbers here, like 1 here and 1 here. Those are different ones. Just for the sake of clarity, let's put strings instead of integers. So strings will be values for elements of the list, linked list, and those guys, yeah, so I mixed a lot. So those guys, actually even worse, that stuff, yeah. We have to compare list nodes to list nodes, right? We don't compare strings to list nodes, because as you remember, the return type should be a list node. So now this looks okay. So you can have multiple cases like that. We can create another list with just one element, and then when we remove it, when we remove the first element from the end, then we're supposed to have none. So that's exactly the case they have here. So one should become none. Yeah. So you may have test cases written like that, and this will be really good if you have an environment where you can run your code. When you have a normal ID, let's say this guy. So you have a normal ID and you can run stuff here. The purpose of this full series of videos is to teach you how to program on a whiteboard. And the whiteboard is quite strange environment. It doesn't allow you to run code, to debug code. Well, somewhat you can debug, and I will show you how. But you don't have access to fun features like code completion or running or anything that fancy. So you have to trust your fingers, and you have to basically be blind and running code in your mind. And yeah, so ideally, even these guys should be removed from Leetcode if you want to prepare for a whiteboard interview. So Then, how do we write test cases if not like that? I've actually already written an example here, so let's just use it. So this will be our first example, this will be our second example, and we can write a bit more of them. Let's say 1, 2, 3, 4, 5, and we are, yeah, we are removing, um, so n equals 1 here, but here we can remove something from the middle, like this guy, which will be its first, second, third element from the middle, and the result should be 1, 2, 4, 5. And also, just to check that we have everything covered, we will have this example where we remove n equals 4, fourth element from the n, 1, 2, 3, 4, meaning the first element, so that it should be like this in the result. So those are cases. We want to double check, or to check, just to check when we run in the mind our program. This is an edge case when we remove this guy. This is also an edge case when we remove this guy, so leftmost and rightmost. This is also a corner case when we check for none, basically. And this is just general case, or let's call it happy case. So now we know all the test cases, all the examples with different variations of inputs. Now let's think how we will proceed. What I propose is to have 2 pointers. Yeah, I know it's kind of a trick because I already know this question and I know how to implement that. But this trick also applies to other programs, other problems which involve linked lists. Because look, if you have an array, which actually should be written like that, because what I wrote here is an array, it's not a linked list, but I was lazy and instead of drawing arrows, I had just square brackets and stuff. But this is supposed to be a list here. But just if we had an array, then the problem becomes super easy. We have to remove n minus nth element from the array, where uppercase n is the size of the array, and lowercase n is what was given to us as the argument to the function, the nth element from the end. For arrays, we know that getting size is a constant time operation, so it's quite fast. And removing the element means shifting all elements which go after it by one element to the left. So 4 becomes 3 and 5 becomes 4, and then we just reduce the size of the array by 1. But yeah, we don't have an array, we have a list. The statement of the problem is that we have to remove nth from the end. We don't know which index is that actually, because we don't know what size of the list is. So what those guys said here, don't do this in 2 passes, do it in 1 pass only. Kind of hinting that the brute force solution would be first to get the size of the list by looping over the list. That would be the first pass. And then the second pass would be remove blah 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 node n minus n, kind of plus minus 1. I don't want to look at which particular element we hit when we address like that. So they said try not to do that. Okay, try not to do. So how then we can solve this problem if we don't know size? That's kind of easy if you know the trick. If you have 2 pointers, then you can solve that. 1 pointer and second pointer, so first and second. And there will be a distance between them. And the distance will be n. So there's a distance between first P1 and P2. By doing that, we can scroll this P1 until the end, and then P2 will stop somewhere in the middle, pointing to the element which we need, right? So this will be one pass, and then as a second step, it will not be a loop anymore. It will be just a second step after all our loops. We will manipulate those pointers somehow. So in order to understand what should we do here, let's rewrite that in a bit different way. So instead of having an array-like representation, let's do it in a list node way. Yeah, it's a bit long to say list node, so maybe we can just say node. Yeah, it will be shorter. So node 1, so this will be a value, and then the pointer will be passed as a second argument. So let's assume we have another constructor here, or just we can modify this, okay, which has two arguments instead of one, the x and the next, yeah, or value and next. So we will rewrite that stuff in a different way. Node 2, node 3. Oh, no, not like that, like this. And then node 4, and then node 5. So now we are closing all those guys, and we don't need square brackets anymore. So here we just pass none, or we can have some default value. So it means that first element will have value 1 and a pointer to second element. Second element will have value 2 and a pointer to 3, and so on and so on. Now let's rewrite it in a bit different way. Let's have separate line for each of the elements in the list, so that the element with value 1 will be on the first line, and, and then the element with value 2 will be on the second line, and then 3, and then 4, and then 5. Now let's see what happens in the case when we have to remove this guy, so that we have to leave only 1, 2, 4, and 5. Because remember, we wanted to remove this middle element. We have to rewire those guys so that this guy will point to element with value 4. Yeah. So we have to set next to this. And next used to point to this element. And 4 used to be pointed by the next of it. So we can rewrite that as, let's say 2, but it's not 2, of course. Next equals next, right? So this is not 2. Let's put some less than and greater than signs just to show that it's an object with value 2. So by doing that, we will skip this middle guy. We will point to the one after 3, yeah, to 4 directly. So now we know how to remove things. Okay, perfect. So we can do it here. This will be our second step. And we can just say P2 here, P2 will be equal to next. So that's it. That's our algorithm. And we didn't write a line of code yet. Well, we have. It's tests. So now we have to progress from here. Now we have to write some code. Looks correct, right? We don't check for corner cases, like what if next doesn't have next, so we dereference none and we have an exception. We will check it. because we will run our program in mind, or debug, let's say debug on the whiteboard using those test cases, and we will see how it goes. Okay, so let's start. Let's have those pointers, but instead of P1 and P2, let's name them somehow normally. So I propose P1 to be just head because we already have head here, and P2 we can call it like a follower. Follower. At the beginning, follower will be just same as head. Why follower? Because follower kind of follows head, but it's n step behind. Okay? So first we have to progress head n steps forward. In order to do that, we have to do some for loop. For I in x range of n, head equals head next, right? Because of this great assumption here, or statement in notes section, n will always be valid. So we don't have to care about cases when n is too large and then head becomes none and we dereference it and we get exception. So we don't have to care about that. If there were no statement like that here, we would have to worry. So you can put a note here, like to do, check for none if n is greater than the length of the list, kind of. But given our conditions, we don't need to do that. Okay, so now we know that head is n elements up front the follower. Why? Why would you say? Do you know what X range is? So it's funny thing. X range is kind of a replacement for range. So range used to be a generator which creates lists. So it will be like n minus 1. So X range does almost the same stuff, but instead of list, instead of a list, it returns an iterator. So it doesn't create this list upfront before doing the loop. It saves us some time and it saves us the memory space. So it's good. Okay, so now um, why head will be exactly n elements upfront the follower? Well, because we know that for our case, like this case, when n equals to 1, we just plug n equals to 1 here. It's 0, so we just remove all those guys. It means that this loop will be executed only once, with I being set to 0 only. And it means that if this guy was executed once, then head went one element further. That's why it stays n elements up front the follower. Okay. Now we have that. Now we have that. Why did we do that? Yeah, that's the question. Yeah, because we had it here. Yeah. That P1 and P2, they have to be n elements one in front of another. But now we have to reach the end. Now we have to go until the end of the list because we have to find nth element from the end. Okay. No, we don't do fors anymore. Let's do a while. While head next is not none, then head equals head next. So we are doing same stuff again, but now we also move follower. Yeah. Okay. Are we sure why I put head next here? What's that stuff? Head next is not none. Means that there is there is something none, not none after the nth element. If we reach this state when next equals to none, then we don't do anything else. So we already reached the end. Okay. But at the same time, head still remains an object. Head is not equal to none itself, and we we can dereference it later. So that's good. But how can we be sure that head is not null? Is not none? Yeah, because it could have turned out to be none after this loop. Yeah. Okay. Let's verify. Let's take this corner case. It can be that easily. So let's do debugging. What I mean by debugging is that we just write those guys here. One and follower equals to one also, because we have that statement here. And then we do one iteration of this loop, and head turns out to be none. Huh? So we cannot dereference it anymore, right? So this is a corner case. And what shall we do in this corner case? Well, what I would like to do, and as the first intent, is to just return none. Because obviously we have a case when we removed the element, and now we have to return an empty list. Now let's say if head is none, then return none, right? Seems to be okay for this case. But then look at this guy. We have another case here. Yeah, let's split them somehow. So we have another case here when we will end up in pretty much the same situation. Why? Well, let's see. Or maybe not. Yeah, maybe I'm just bullshitting you. But let's see. Let's see. Let's debug. Because we have this powerful debugger on the whiteboard. We can use it. At the beginning, both guys are set to this element. Then we do just one iteration because n equals to 1. We do just one iteration, and head turns out to be 2, not none anymore. We don't fall into this case. But there should be a case similar to this one when we will follow. So we will fall into this case. Whoop, whoop. Yeah. It's this one. Wow. When we remove this guy. Let's try debugging again. We have two elements here now because n equals to 2. It means that there will be values of I 0 and 1. So 2 iterations. And then for the first iteration, head will be 2, and then for the second iteration, n would be none. Ha! Okay, so now we fall into this case. And returning none will not work, right? Because we expect this as an answer. We don't expect none as an answer. Wow, what can we do here? I don't know. Let's just look at the result and let's try to analyze that. It happens only in cases when n equals the length of the list, right? Here we had the length of the list 1 and n was 1. Here, same stuff, length 2 and 2. So when this stuff happens, then over this loop, head starts to point at none, but we actually had to remove only this first element. And what we can do here is we can just return follower.next. Let me explain why. Because follower still points to the original position of head. And the original position of head was 1. And then we can still see it here, right? Follower is 1. Okay, it's not one, it's an element with value equals to 1. But still, we can say it. And the next to it is 2. So 1 dot next is 2. So if we just return follower dot next, then we basically say, yeah, return same thing as you passed to me at the beginning as a head, but starting from the second element, not from the first one. That's what we are saying. Okay. So we covered this corner case, and actually all corner cases when we have to remove the first element. Or in other words, all cases when n is equal to the size of the array or of the list. Fine, so we are good here. Now we can continue and safely dereference head, because at this point head is not none anymore. We covered this case. Fine. So let's see what we have here then. Those guys will not apply to us anymore, only those guys. So let's just put it here. Wow. Now we have head pointing to 2 and follower still pointing to 1. Now we can continue and we can say while next is not none, do that stuff. But you see, we don't have that case. We actually have next pointing to none because head is this guy. Yeah, head points to this guy. And it has next set to none because it's the last element in the list. Okay, what we have to do? We have to take another example. Yeah, let's take a bigger example. Well, let's just take it. So we have that set up. Let's quickly run through this loop. In this case, we will have 3 iterations. So head will go to 2 first, and then to 3, and then to 4. Now we can use it here. Okay, so let's see what happens. We have head pointing to 4th element and none. So next is not none. So we continue. Head now points to 5 and we move the follower also. 5 has next pointing to none, so we stop. We just had one step there. Interesting. Follower now points to 2, which means that we can just do this trick with double nexts that we had here. Yeah, let's just copy that. So we can do this trick, and then we will say 2.next equals 2.next.next. So 2 will point to 4, right? Let's do that. That's it. We are done. Let's just return follower. Yeah, let's hope it's okay. Wrong answer. Yeah. Why? Because for 1 to 3 we return 2. Oh. Yeah, because we didn't have to return follower. Yeah, that's the thing. So I cheated here because I used the submit solution thing. In the interview in real life, you don't have that luxury, so you have to be really, really careful when doing stuff. So let's just save our original head here and let's return it. And then let's rerun. Yay! Accepted. That's nice. To quickly recap, now we know how to write test cases in commands, how to reason on the whiteboard, how to debug on the whiteboard, and also how to write unit tests. Well, not exactly. I only showed you how they look here, but I didn't run them in the real IDE. I'll do that in the next video. So like this video, subscribe to my channel, and watch following videos. Have a nice day, and good luck at your interviews. Bye bye.